What if I ask you what are the sum of the interior angles of a concave polygon? I'm sure you're going to be in a doubt. Well, don't be. Here in this lecture, we will be discussing about the sum of the interior angles of a concave polygon, as well as that you already know, that is the sum of the interior angles of a convex polygon, that is 2n minus 4 times of 90 degree. But you're not going to tell it blankly, as here we'll also be looking up a proof of how to say that the sum of the interior angles of a convex polygon is 2n minus 4 times of 90 degree. So for all confidence and to be able to understand mathematics so that you never forget it and you enjoy it, make sure that you're with me in the mathematics helpline with me, your host, that is Sourobh Kumar Dotto. So let's begin, children, and let's first unravel this fact that what is actually the sum of the interior angles of a concave polygon. I'm sure when anybody tells you that it is about a convex polygon, you all know that it is going to be 2n minus 4 times of 90 degree. What if this is a concave polygon? That is where you are in a dilemma. So this is where I'm going to help you today. Now this is for a convex polygon, and now if you talk about a concave polygon, as simple as that, both of these are exactly the same. So that's a joke, right? You must be thinking that sir kept us waiting just to tell that it's going to be the same. Yeah, this is how actually you remember, right? So if you talk about a convex polygon or if you talk about a concave polygon, remember that the sum of the interior angles is 2n minus 4 times of 90 degree. Now that you know this, let's go to the next step and try and prove that if you have a convex polygon, that is one which has all of its interior angles lesser than 180. Here this is a hexagon, and you will not be able to find a single vertex where the angle is greater than 180 degrees, or in other words, we can say that all of these angles are either acute or obtuse. None of these are reflex. If at least one would have been reflex, right, then this triangle would have been, this polygon would have been said to be a concave polygon. Okay, now children, to prove this, that the sum of the interior angles of a convex polygon is 2n minus 4 times of 90 degree, we do a simple construction. That is, we take up a point within this triangle, and then what we do is we then make some straight lines to make some triangles, right? Now to do that, here let's say we have one of the straight lines to be drawn, say like I said, from anywhere. So let's make this to be one of the straight lines, and then drawing this straight line, we will now have our first triangle. So this is the first triangle. Then similarly with each of these sides, we will have as many triangles, right? I'm sure you people must be thinking that we were talking about polygons. From where did this three-sided polygon come? Well, this is going to help us, as if you've fallen in the well. To be able to prove it, this guy is going to put down the rope and pull you outside. Just see how. Okay, so here as you see that all of the triangles have been formed, and there's just one which is left out, and that is this. Okay, so here as such, now you have all the triangles which are formed, which are to be on the vertices, right, rather which are to be through the vertices, right, and this is the last one. Okay, so here as you see that the number of sides are actually 1 2 3 4 5 6, right, and the number of triangles are also 1 2 3 4 5 6, right? So as many sides you have in the convex polygon, that many triangles are going to be formed in the convex polygon. Now what to do with this, I'll tell you. So as this is a theorem, so first you require to write that this is a theorem and then do it like a theorem. So can you actually tell me what do I mean by saying do it like a theorem? Yes, Manisha? No? Well, in a theorem, remember, as you've seen in your books, we write some statements and then we have some reasons. So similarly, we are going to do here on the left hand side, we'll be writing statements. So can you actually tell me what are statements? Well, statements are those which are what you've done, right? or what you're going to do, right? And if you talk about reasons, it's why you've done this, right? So this is how actually you tend to prove a statement, which is the theorem. Now here, children, as we have the statement of the theorem that we have to write, so we will write this now. That is, along with me, you all also write, and then you'll be able to understand this much more. Okay, so sum, I hope you're writing. Yeah. So for that, make sure that you're also seated on a table and chair. That will always help you to study and not become lazy. Otherwise, what will happen is gradually you'll tend to have a little pain on your back. You like to slide a little and then go to sleep. Once you sleep, your studies are done. So make sure you're always seated on a table and chair, straight, and then focusing towards your studies. I'm sure this is always going to help you in studying more. Okay, so let's get back. Sum of interior angles, right, of a convex polygon, right, is 2n minus 4 times of 90 degree. Now some people also say it this way, that it is 2n minus 4 times of right angles, as every right angle is 90 degrees, so it means the same. Now there's another way to write this. If you just look at this, then we can write 2n minus 4 times of 90 degree, which can also be written by taking the 2 to be common outside. As such, we will now have n minus 2 times of 2 into 90. So as such, this then can be written to be equal to what? Then it can be written to be equal to n minus 2, right, which is going to be multiplied by 180, right? So you can say n minus 2 times of straight angles, right, because angle on a straight line is 180. So this is another way which these angles can be talked about. Now how to prove it? Now you remember we talked about these triangles. Now we're going to do something about these triangles. I'm sure all of you people know that whenever we have a triangle, some of the interior angles of a triangle, right, is equal to 180. So what do I mean by the interior angles of a triangle? I actually mean to say that if you talk about this angle, or if you talk about this angle, or if you talk about this angle, this will actually form the interior angles of a triangle. And similarly, if you try now adding up the interior angles of all of these triangles, it is going to come to 180 into number of triangles formed, right? And as we've already looked up, that the number of triangles that are going to be formed will be n in number, that is the n-sided convex polygon. Thus we now have our first statement, that is, we will say that sum of all interior angles right of all triangles formed. Now you know that there are n triangles which are formed, right, is 180 degree, which is going to be multiplied by n. That is because one has 180 degrees, so obviously n will have 180 into n degrees. Now here, children, we are going to write the reason, that is simply the sum of interior angles, right, of a triangle is 180 degrees, and that is the reason why we've been able to write this. Okay, now children, we come to the second point. The second point is, if now we try and actually get inside and analyze what the angle of these triangles are, actually we have two type of angles here. One, which are the angles which are there at the vertices. So when we talk about the angles of both of these triangles, we'll actually be including this interior angle of the polygon, right? So here at the vertex, what is the angle? It is actually this interior angle plus this interior angle of both the triangles, right? And when we are wanting to find out the sum of the angles of all the triangles formed, obviously we are talking about two type of angles. One are the interior angles of this polygon, and the other are the angles which are getting formed at the top of the triangle, and that's actually angle about a point. Like if you talk about this is a point, and if you talk about adding up all of these, this is actually adding up the angles about a point, and that you know to be 360 degrees, right? So if you just talk about here these angles, right? So these angles are actually what? These angles are the ones which can be said to be the angles about a point. So here I will say angle about a point. For that matter, I will also name this point because this guy is feeling a little nameless, right? I didn't say shameless, right? I said nameless. Okay, so let's name this point to be, say, some point P. So this is some point P, right, about which we are talking, right? And here we can also name each of these vertices to be, say, some A, B, C, D, E, F. Okay, so two type of angles. One are the interior angles of this convex polygon, and the second are the angles about a point. So this is what is going to be our next statement, that is interior angles of convex polygon, right, to which we are going to add angle. Rather, we just write 360, then we state the reason, plus 360, right? That is angle about a point, right, is what is going to be this that we've just talked about, that is a 180 degree, which is multiplied, that is sum of the interior angles of all the triangle, right? Now here we can say that angle about a point, right, is 360 degree, and this is a theorem that you already studied earlier, right? So as here, thus we have stated that the angle about this point P is going to be 360. So if to 360 you add also the interior angles of the convex polygon, which are actually the adjacent angles of these triangles, which are just side by side or laterally placed, right, then we have it to be equal to sum of the interior angles of all of this triangle. Thus we can equate both of these, and if you take the sum of the interior angles of the convex polygon to be, say, some x, then very easily we will be able to find out this expression for which we have actually set out. So next, now what you can do is we will now be talking about that if thus we talk about this x, right, to which we add 360 degrees, right, we should be able to get 180, right, which is going to be multiplied by n. So as you know that we've got to make x the subject of the equation, right? So what we do is, now making x the subject of the equation, we will have x to be equal to 180n, right, obviously in degrees. So here degree from which 360 is going to be subtracted, right? Now here further what you can do is, as you find that this 180 is common, so let's take this out, right, and then you have n minus 2, which is inside. So if you put the 2 inside, then you can say that you have this to be, say, 90 into 2. This is how you can write 180, right? This is multiplied with n minus 2. As such, here you can say that you have here 90 degree, which is going to be multiplied with 2n minus 4, right? Thus 2n minus 4 times of 90 degree is actually sum of all the interior angles which x is representing. And here we can write the reason that this is, why have we been able to write this? That's because of the statement 2, right? So here we will say that because of the statement 2, right, we can actually write this, and therefore this stands to be proved that the sum of the interior angles of a convex polygon is 2n minus 4 times of 90 degree. So all of this might have some doubt somewhere, but I'm gonna not let it loose. Like I told you, I'm gonna make you understand this once and for all. So let's get started again and let's discuss all of this so that there is no doubt of ambiguity. So here, children, we have a convex polygon. That is, at all of these vertices, the interior angles are such that they are less than 180 degrees, right? Now, what we put to prove is what is the sum of the interior angles of this convex polygon, and then if we add up all of these angles, it should come to 2n minus 4 times of 90 degree. This is what you've been told and you know, right? And now we're going to prove it. That is, we have to show that we have solid proof now that we say this, right? Okay, so the theorem says sum of the interior angles of a convex polygon is 2n minus 4 times of 90 degree. Now, in order to prove it, what you've done is we've taken a point P which is within the convex polygon, and then we've joined this point to each of these vertices, right? Now that you've joined it to each of these vertices, you now have n number of triangles, that is as many number of triangles as many are there to be the sides of the convex polygon, because each of these sides have been used up to make a single triangle, right? So as this is a hexagon, this has got 6 triangles. So if you make a polygon of say 9 sides, then you're going to have 9 triangles in that polygon, which will be formed by any point which is in the interior of the polygon. Next, now to prove this, the first thing that we're going to say is that the sum of the interior angles of all of these triangles formed is going to be 180 into n. That's because sum of the interior angles of each of the triangle is a 180 degree. So as there are n triangles which are formed, so obviously it's going to be equal to 180 into n, right? So you see the reason, the sum of the interior angles of a triangle is 180 degrees. Okay, next now we talk about the next statement, that is, if you now try to break up all these angles, you find that these angles are actually of 2 types. One, which are formed on the vertices of this convex polygon inside the convex polygon. That means they are the interior angles. When you add up this interior angle of the triangle and this interior angle of the triangle, it will become the interior angle of this convex polygon, right? Similarly, if you add this interior angle and this interior angle of both these triangles which are adjacent to each other, it will actually give you this interior angle of the convex polygon. Thus, you're actually adding all the interior angles of this convex polygon to the angles which are the sum of the angles about this point P, right? And as you know that the sum of angles about a point is 360 degrees. Thus, we are actually talking about the interior angles of a convex polygon to which is added 360 degrees. Now, how can we say that this is 360 degrees? That's because we are talking about the angles about a point which is always known to be 360 degrees. Now, as you know that the sum of these angles is the sum of the interior angles of a convex, a triangle, right? And thus, we have earlier proved that this is 180n, and as such, this can thus be again written to be 180 degree, which is multiplied by n. That is the above statement that we have written. We have now written it in terms of the sum of the angles of all the triangles, right? So further, there is this thing, if you write, then there'll be more understanding, is equal to sum of interior angles right of a triangle. Okay, so this sign also represents a triangle, right? So this is how you can write a triangle also. Okay, so as we have above just looked up that the sum of the interior angles of all of the triangles which have been formed will add up to 180n, right? So this 180n is actually sum of all these interior angles formed in the convex polygon, to which the angles about a point, that is 360, can be added, right? Now thus we have x, which is the sum of the interior angles of the convex polygon that we got to find out, right, plus 360, that is the angle about a point, which will become equal to 180n. Now we take this 360 to the other side so that we can make x the subject of the equation and calculate its value. Now how can we do this? That's because we're talking about statement number 2, where we already proved this, right? So this is the reason. Now we are going ahead with this reason to try and prove a point. Now further, we have 180, which can be taken common from this pair of terms in the binomial. So 180 degree, when taken outside, inside in the first term you're left out with n, and in the second term you're left out with 2, right? So further, this 180 can actually be written to be 90 degree into 2, right? And if you take this 2 inside, this is going to become equal to 2n minus 4 times of 90 degree, or in other words 2n minus 4 times of right angles is the sum of all the interior angles of a convex polygon, right? So this P actually stands for proved, right? And thus we've been able to prove, I think there's a single O in this, right? So we've been able to prove this. So this is proved. And how do we write this in geometry? We write quad erat demonstrandum. So this is another new thing that you got to know, that when we talk about this QED, this in Latin means that it stands proved. And how do we say it? We say that this is quad erat demonstrandum. Okay, so this is how we've been able to understand about how we can find out the sum of the interior angles of a convex polygon, and it comes out to be 2n minus 4 times of 90 degree. And now you also have a solid proof of this. Well, I'm sure you also now must be clear about the ambiguity that you had, that what is it going to be the sum of the interior angles of a concave polygon. Now that I know that the sum of the interior angles of a convex polygon is 2n minus 4 times of 90 degree, well, it is going to be exactly the same, right? So do you remember, whether you talk about the sum of the interior angles of a convex polygon or that of a concave polygon, it is always going to be 2n minus 4 times of 90 degree. Now children, I'm sure you people must be clear about this, so do write in comments how you understood this and what is your next problem or your next topic which you want me to cover up. I will cover it up and I'll make sure that you understand that for sure. Now, as you know that studying just little, that's not going to help you, right? So you want to get into the fast track where you can learn all of this as you understood this all for the whole of your mathematics, right? So you might be having a specific concern that you probably are in IB board, or say in IGCSE board, or probably ICSE board, or might be CBSE board, right? Any board world over, right? If you have a problem in mathematics, make sure that you click on the link which is there in the description. It's a Google form link. Tell me what you need and you'll get me coming back to you and helping you out. So tell me your problem, I'll help you. And make sure that you practice this one so that if anybody now asks you, you will be able to answer and you'll be able to tell that this is why it is, right? So you have the reason that the sum of the interior angles of a convex polygon is 2n minus 4 times of 90 degree, and you can easily state it. So make sure you do this, and then there'll be a link which will be there in the description. That'll be a practice question. So make sure you reach there and also do the practice question. Bye. This is Sourobh Kumar Dotto from the Mathematics Helpline signing off. Bye. Meet you people soon.